Hello guys, welcome back again. I will solve questions on data representation from this year. And the question goes thus: real numbers are stored in the computer system using floating point representation with 10 bits for mantissa, 6 bits for exponent, two complements formed for both mantissa and exponent. Calculate the binary value of the given normalized floating point number. So the first thing to do is to what? Is to calculate the exponent, okay? So for the exponent, this is 1, 2, 4, 8, 16 minus 32. So you add the ones, which is, for this is 8 plus 1, and that is 9. Then that means, then for the mantissa, then this is 0, 1, 0, 0, 1, 2, 3, 4, 1, 2, 3, 4, 0, 0. So the decimal point is here. Having an exponent of 9 means you move the decimal point to the right 9 times. If the exponent is negative, you move it to the left. Is that understood? So let's move it to the right. That gives us 1, 2, 3, 4, 5, 6, 7, 8, 9. So that implies that this is 0, 1, 0, 0, 1, 1, 1, 1, 0, 0. Okay. Now then write the place values. The place values are 1, 2, 4, 8, 16, 32, 64, 1, 2, 8, 2, 5, 6 minus 5, 1, 2. So you add the ones like I said. So the ones is 2. That's so the mantissa is no, not the mantissa, the general value rather is equal to 256, okay, plus 32, then plus 16 plus 8 plus 4. Okay, so these are the general value. So let's add that together. The use of calculator is not allowed, don't forget. So 16 plus 4 is 20. 20 plus 8 is 28. So 32 plus 28 should give us 60. Then 256 plus 60 is 6. 1, that is 316. Okay. So the answer is 3. So you come back here to this answer space and write 316. You should write your answer in this space because everything in this space is for working. So if you write a 316 here and you don't write here, that means you haven't written the answer, you only showed the working. Okay. So that is the first question, 1A. So for question 1B, you are asked to convert this into normalized floating point representation, that is the binary value. So the first thing is to take the minus out, don't touch the minus. So this is 102, then dot 75. So the first thing, convert 102 to binary. So 102 divided by 2. So 10 divided by 2 is, so 102 divided by 2 is 51, remainder 0. Okay. For 2 times 1 is 2, 2 times 5 is 10. Then this is 25, remainder 1. But 2 times 25 is 50. And this is 12, remainder 1. 2 times 12 is 24. 6, remainder 0. 3, remainder 0. 1, remainder 1. 0, remainder 1. You count it up. So this gives 1, 1, 0, 0, 1, 1, 0. So because it's a positive number, then there should be a leading 0. Okay. Then this should be minus 102.75, like I said earlier. Then this should be minus, don't touch the minus, don't forget. Then that should be 0, 1, 1, 0, 0, 1, 1, 0 dot. Then for the decimal number, to convert it to base 2, you have to multiply, unlike the whole number where we divide. So this is 0.75, so you have to multiply by 2. You keep multiplying until it converts to 0. So 2 times 5 is 10, 2 times 7 is 14 plus 1, 15. 2 bits, 2 bits, the third bit is the remainder. Then this is 0, this is 10. So that has converged. So that will be 0.11. I hope this is understood. Okay, good. Then the next thing is to convert this to two's complement. Okay, so that will be 100110001.00. I hope this is understood. So then you add 1 to this value so that this gives 100, yes, 11001.01. So this is the two's complement of minus 102.75. Then let's write the mantissa. Then the mantissa is 100110001, then 01. So the whole number is a mantissa. So to get to exponent, you move the decimal point as far as 1.0 can be achieved because this is a negative value. If it is a positive value, you move the decimal point as far as 0.1 can be achieved. So for a negative value, let's move 1, 2, 3, 4, 5, 6, 7. That means exponent is equal to 7. Then this should be 111,000 because 7 is 111. I hope this is well understood. Okay, good. So the next question will be solve from October, November 2023 and question 1. So it states that real numbers are stored in a computer using floating point representation with 12 bits for the mantissa, 4 bits for the exponent, two's complement form for both the mantissa and exponent. Write the normalized floating point representation of 0.65.25 in the system. So to solve this, we have to separate the whole number from the decimal, which is 65.25. Okay, then convert 65 to base 2. You can do that in your rough sheet. So this should be 2 in 6 is 3, 2 in 5 is 2, remainder 1. Okay, that is 32, remainder 1. So 2 is 16, remainder 0, 8, remainder 0, and then this should be 4, remainder 0, 2, remainder 0, 1, remainder 0, and 0, remainder 1. Then you count it up, then you should give me 1, 1, 2, 3, 4, 5, 5 zeros, 1, 1, 2, 3, 4, 5, and 1. Then there should be a leading 0 because we are converting 65 to base 2. Okay, then this should be 0, 1, 5 zeros, 0, 0, 0, 0, 0, 1. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Always convert in your exam. So that is 65 to base 2. Then the next thing is to convert dot 25 to base 2. Okay. So like I told you earlier, dot 2, we are converting decimal numbers to multiply by 2. Okay. When you multiply by 2, 2 times 5 is 10. 2 times 2 is 4 plus 1, 5. So there is no remainder. Okay, then you multiply by 2 again. 2 times 0, 0. 2 times 5, 10. Then there is 1 remainder. So you count it down like I said. Then this is dot 0, 1. Okay, then you move the decimal points to the left as far as 0.1 can be achieved because this is a positive number and not a negative number. Okay, and that should be 1, 2, 3, 4, 5, 6, 7. That means exponent is equal to 7. Okay, exponent is equal to 7. Then this should be 0, 1, 1, 2, 3, 4, 5, then 0, 1. Okay. Oh, I made a mistake while writing this. Then this should be 0, 1, then 1, 2, 3, 4, 5, 5 zeros. 1, 2, 3, 4, 5. Please don't forget to always count. Then 1, 0, 1. Then you fill the border spaces with 0, 0. Okay, fill it with 0, 0. Then the exponent is 7 is 1, 1, 1. So that is 1, 1, 1. Then the exponent is 0, 1, 1, 1. I hope this is understood. So the next question states, explain the problem that will occur in storing the normalized floating point representation of 65.2 in this system. So like I told you earlier, If you want to convert decimal point to binary, you continue to multiply by 2, isn't it? And you get to a point where you can no longer proceed, or you get to the maximum number of bits allowed for exponents, or for mantissa rather, okay? The mantissa here is 12 bits for mantissa and 4 bits for exponent. 12 bits implies that this 65 has taken 1, 2, 3, 4, 5, 6, 7, 8, 8 bits. So exponent should not take more than 4 bits. Is that understood? That is what it means. So everything completes 12 bits. So the target for multiplying this dot to 0 is to obtain 4 bits. I hope you understood that. So you multiply by 2, 2 times 0 is 0, 2 times 2, 4, the remainder is 0. Multiply by 2, 2 times 0 is 0, 2 times 4, 8. Multiply by 2 again, 2 times 0 is 0, 2 times 8, 16, then the remainder is 1. Multiply by 2, 2 times 0 is 0, 2 times 6, 12, the remainder is 1. Multiply by 2, 2 times 0 is 0, 2 times 4, 4, the remainder is 0. It continues, it will never converge. It will continue, it will never converge. So with this, that means that since it can never converge, just take the first 4 bits. Do you understand? If you take the first 4 bits, combine it with this 65 and convert it back to January, you will never get 65.20. You will never get 65.20. Do you understand? So that means that this number cannot be what? It cannot be represented exactly. It cannot give an exact representation. Do you understand? So this cannot give what? An exact, that is the problem. So that means you have that the decimal fraction that will be 65.20 cannot be cannot be represented exactly. Do you understand? So if it cannot be represented exactly, what does that imply? So that means there will be loss of precision. Do you understand? There will be loss of precision because instead of getting 65.20, this cannot be represented. Then it is only 65.1875 that can only be represented, which is not 65.20. Do you understand? Then there will be what? There will be loss of precision. So the second problem is there will be loss of precision due to rounding error, okay, or better still, due to truncation. Because we have to ignore the other values and just take the first four values. Is that understood? So that is the correct answer to the question. I hope this is well understood.